Good morning, ladies and gentlemen. Welcome back to Physics 30. And today we're going to be doing part 2 of Coulomb's law. So last video, we were looking at the equation itself and the theory itself. Now we're going to be looking at net electrical forces. So what this means is we're going to be having two forces acting on an object. So we're going to start with linear, and then we are going to switch over to two-dimensional. So, ladies and gentlemen, this is very, very similar to what we did last year with net gravitational forces. So when you have two masses acting on each other, now we're going to be having two charges acting on each other. Or I guess three charges, I should say. So very similar to what we did last year. So if you want to go back and re-watch some of that, those Newton's universal law of gravitation and gravitational fields equations, watch those videos and re-look for some of this stuff if you want more of a brush up on that general concept from last year. So, ladies and gentlemen, let us begin. So, when we're going to be looking at the force exerted by two charges on our two charged objects, we need to keep in mind our electrostatic and repulsion and attraction rules. So, remember how similar charges repel and opposite charges attract. That's really where it's going to come into play here. And this is where we're really going to see those absolute values being needed. We'll be adding on our positives and negatives using the laws of electrostatic attraction and repulsion after we've done our calculations. All right? Okay. No better way than to jump in the deep end. So let's get into our math. So, ladies and gentlemen, we have a charge Q1 is placed 2 centimeters from a second charge Q2, and the second charge is placed 5.5 centimeters from the third charge Q3, as shown in the diagram. There's the diagram. And calculate the net charge, or the net, electric force on the 1.7 times 10 to the power negative 6 Coulomb charge. So that's this red guy here. So Q1. So the net force on Q1. So Q1 is where we're going to be doing all of our focusing. We're not worrying about the impact that Q2 and Q3 have on each other, as we are worried about Q1. Okay. So once again, ladies and gentlemen, you need to watch your units. Okay. So really, really watch your units here. So you're going to have your 0.02 meters here and your 0.02 meters. So here you're 0.055 meters. So watch out for that, okay? All right. So I'm going to scroll down a bit here so we can still see what we're looking at. So the first thing that we're going to do is we're going to calculate our electric force that Q2 is going to be applying to Q1. So I am going to call this F, I don't know, what do we want to call it? I'm going to call it 2. Because it's what Q2 is applying to F1, we'll call it that. So it's going to be your K, Q1, Q2 divided by R squared. So same as what we were looking at previously. And just for sake of space, because we're going to be doing a couple of these, we're just going to put it in this way. Okay, so you're going to use from the back of your data sheet. I actually found my data sheet today, so that is a good thing. It was underneath my writing tablet, but I found it. So you can find K on the back of your data sheet, right there. Okay, so you don't have to memorize it. And that is your 8.99 times 10 to the power 9. And these are in coulombs, so we don't need to convert those. So 1.7 times 10 to the power of negative 6. And then 2.5 times 10 to the power of negative 6. Absolute values, so everything is positive. Divided by your R squared, making sure you've got your units converted, so your 0.02 meters, square that. Okay, so you are going to wind up with F2 as 9.5. I put my decimal in the wrong spot. Ips. All right, 95.51875 dot, 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 dot. Okay, newtons. So now we need to think, what direction do we want to be negative and what direction do we want to be positive? Well, I'm going to choose left is going to be my negative direction and right is going to be my positive direction because that's just kind of common. All right. So now we need to think. Q2 and Q1 are both positive charges. So what are they going to do? Repel. So because these guys are going to be repelling, what direction is Q2 going to push Q1? Left. Q2 is going to repel Q1, so it is going to be pushing Q1 to the left. So I am going to make that negative, not because of the charge, because of the direction that Q2 is pushing Q1. Okay, with me so far? All right. I'm going to call this next one F3 because it's what Q3 is going to be applying to Q1. So same equation, Q1, Q2 over R squared. Now we know this is a negative charge, but remember absolute value, so don't put the negative in the equation. That's going to come later when we're determining our direction. So 8.99 times 10 to the power of 9. And then our Q1, so 1.7 times 10 to the power of negative 6 coulombs. And then Q2, absolute value, so don't put that negative in there, 2 times 10 to the power of negative 6 coulombs. Now this is where it gets interesting with the radius. We need to take into account both of these guys because we are looking at the distance between Q1 and Q3. All right, so you're going to have to add these two different radii together here. All right, okay, so 0.02 plus your 0.055, square that. So watch for that in these questions. So these are really, really tricky when it comes to that. So pay very close attention to that direction bit or that distance bit, okay? Okay, lesson subtle hint. That's one of the tricks. Once you plunk that into your calculator correctly, you are going to get 5.43395 newtons. Now let us go back and think about our direction. So we've got Q1 here, which is a positive charge. We've got Q3 over here, which is a negative charge. We are focusing on what is Q3 going to, or how's Q3 going to impact Q1? Well, because Q3 is negative and Q1 is positive, Q1 is going to be attracted to Q3. So it is going to be pulling Q1 towards Q3. So that means it's going to, the red object here is going to be pulled to the right by Q3. So then we chose right to be positive. So that's going to be a positive force because we decided right to be positive. Okay? All right. So that's definitely one of the tricky parts about this is applying that laws of electrostatic attraction here. And that's where what the tricky bit's going to be. Okay. Well, then we're going to need our F net, so which will be F2 plus F3. So you're going to take our negative 95.51875, use all those numbers in your calculator, plus 5.43395, ... use all those numbers. Okay. And we're going to wind up with a value I did this earlier. Let me scroll down here. Negative 90.084 newtons. All right. So, as always, sig digs, units, direction. Okay. And I didn't say magnitude of net force. I said, what is the net force? So I want direction. All right. So our answer is negative. Sig digs, when you look at sig digs, I want 2 sig digs. So this is going to round to 90. And then I am going to use my units, newtons. My direction, this is negative, and we decided that negative was left. So I communicate my direction as left. Sounds good? Cool beans. All right. So, ladies and gentlemen, that is on 1 dimension. Now we get into 2 dimensions. Very exciting. So the concept is going to be very, very similar, except the difference is trig is going to be involved, as well as some Pythagoras. Okay, so 3 charges are arranged, and as in the following diagram shows, determine the force on Q2. Okay, so here's Q2. So we're focusing on this pink structure. Now, once again, watch your units. Always watch these units. Okay, we've got microcoulombs. So you're going to have to convert these units. And micro is the times 10 to the power of negative 6. So this is actually 2 times 10 to the power of negative 6 coulombs. Okay, so you can convert these units right now. That's what I would do. Just get it done. Okay. All right. Okay. So I am making the assumption at this point that you guys are comfortable with converting units like that. If you are having grief with it, make sure you come see me, okay? All right, and we can get her figured out. All right, so for this one, ladies and gentlemen, the principle is going to be the same, except we now need to think about our angles afterwards. So the very first thing we're going to do is we're going to find our F1, so the impact of Q1 on Q2, and we're then going to find our F3, so the impact of Q3 on Q2. And then we'll be thinking about the directions, and then we'll do some trig. Sounds good? All right. So let us start. Let's start with, I'm going to call it F1 because it's going to be the impact of Q1. And our same equation, Q1, Q2 over R squared. And we're going to take your numbers and we're going to plonk those in there. Our units for our radii are okay. So K from your data sheet. And then Q1 is your 2 times 10 to the power of negative 6. And Q2 is 1 times 10 to the power of negative 6. And then our radii of 3 meters, oops, not to the power of 9 is squared. 3 squared is 9, so that's why I wrote the 9. It's just thought 9, I guess, and wrote 9. It happens. We're all human. Okay, so when you plonk that into your calculator, we're going to line it with the magnitude of 1.997 times 10 to the power of negative 3 newtons. So a little force. Okay, so what we have now is to think about our directions here. Okay, now a simple positive and negative isn't going to work. Why? Because we're on 2 different dimensions. We now need to be thinking about, is it going to be north? Is it going to be south? Is it going to be east? Is it going to be west? So therefore, we really, really, really need to be careful with that. All right. So if we're dealing with something on the 2-dimensional, you're going to have to be thinking in your 2-dimensional vectors and your 2-dimensional directions. Whereas if we're going to be dealing on the 1-dimensional, we can just do left and right. Okay, so let's look at this guy. We have 2 positive charges here. Okay, now we are thinking from the perspective of Q2, this pink Q here. Okay, because we're thinking from the perspective of Q2, what is Q1 going to do to Q2? Is it going to attract it to itself or push it away from itself? It's going to repel because they are both positive charges. So, and we're thinking, what does Q1 do to Q2? It's going to repel it and it's going to push it south. Okay? So I'm going to write my direction of south. That is going to be more useful to me when I go to draw my triangles, because you're absolutely going to be drawing triangles, than just a positive or a negative here. Okay? Okay. So now we are going to look at our next force acting on Q2. So I'm going to call it F3 because it's the fourth applied by Q3. So that's equal to K. That's a wonky K. Q1, Q2 over R squared. And this guy from your data sheet, same value as always. And then now for this guy, we're going to be looking at these two here. So 1 times 10 to the power of negative 6 coulombs multiplied by 4 times 10 to the power of negative 6 coulombs. Our radius is 4 meters. I nearly did it again. I nearly wrote like 16. You could write 16 if you want, but I'll write it like that to be consistent. Okay. Once you plunk that into your calculator, you are then going to get the correct number of 2.2475 ... times 10 to the power of 3 newtons. Excuse me. So we are going to need to think, once again, from the angle and perspective of what is Q3 doing to Q2. So Q2 and Q3 are both positive. They are both going to repel each other. We're thinking from the perspective of what is happening to Q2. Q3 is going to repel Q2 and push Q2 west. All right. So now we have south and now we have west for a direction. So what does that mean? Pythagoras-centric. Oh yeah. Let's scroll down here. We don't need the diagram up there anymore. We have our numbers. So once again, remember that there's 2 correct ways to orient your lovely triangles. I'm just going to do it one way, and then just remember that if you get an angle, it is the complementary angle. Subtract 90 from that, and you'll get the same answer. But if you have a complementary angle, just remember your direction, your reference is going to the direction is going to be complementary as well. So just remember that bit. Okay, so F1 is going south. F2 is going west. Your resultant, your net force, is going to be going like this. Okay? Your angle is always from where you started, so that's going to be your theta. All right? So we're going to call it our F net as your a squared plus b squared square root. I just rearranged Pythagoras. Okay, so F1 is going to be this guy. And so your 1.997 ... times 10 to the power of negative 3, using all those digits in your calculator. Square that. 2.2475 ... times 10 to the power of negative 3. Use all those digits in your calculator. Square root the lot. Okay. So once you do that, you are going to get your magnitude of the F net of 3.007 dot, 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 times 10 to the power of negative 3 newtons. Okay. We now need a direction, because I said net force in that question. I did not say magnitude, so I want a direction. Okay, because force is a vector. Oh yeah. So, my theta, I'm going to be using my tangent. The reason I'm going to use tangent is to reduce the multiplication of errors. Because anytime you do math, there's going to be some error, especially with your irrational numbers. So, and this is an irrational number because your calculator can only have so many digits. So by using the numbers that have the least amount of math on them, you're going to reduce that type of error. And I know it seems insignificant in a two-step question, but in university, when you're going to be doing like huge, much longer calculations, or if you want to be an engineer or something, you're going to have even huger, longer questions of math, that where every number builds on the other, you can really get some serious multiplications of errors in there. And like it happens in chem too. At university, I did a chem lab, and I just synthesized this compound in organic chem, and it was a tough multi-step process. And every single step, there's an error, right? And those in my undergrad organic chem class who'd done well, like a 1% yield or something. Yeah, I had a 0% yield on mine. I was kind of embarrassing. I'm looking at my filter. I'm like, I have no product. I don't even have anything to weigh or analyze. I had to borrow product from somebody else at like a 1.5% yield. So it happens, right? So anybody to avoid error at any step of the process is the way to go. So you don't wind up with a 0% yield in your organic chem lab. Okay, so now what we're going to do is tangent. Okay, so theta, your tan negative 1, and the opposite is F2. So that is going to be F2. That should technically be your F3, beg pardon. So your F3 is your opposite. So 2.2475 times 10 to the power of negative 3. Use all those digits in that calculator. F1 is your adjacent, so 1.997 times 10 to the power of negative 3. Make sure your calculator's in degrees. We don't want to have a rad time. Radians. Yeah. Okay. Once you put that in your calculator, you are going to get your value of theta to be 48.366 ... degrees. Now we need to put it all together. Okay, with correct sig digs, all that good stuff. Okay, so how many sig digs do I want? 2. All right. So 3.0 times 10 to the power of negative 3. Okay. Units, newtons. And then your direction, once again, 2 sig digs. So that's going to round to 48 degrees. And then our direction, we need our reference with our direction. Okay, so here is, you start at this guy here. It's, okay, going to be west of south. What is the second correct answer I'll take? -90 minus 48, and you're going to get 42 degrees, and the reference is going to be south of west. So either of those are correct. And if you're ever in a multiple choice scenario where it gives you, say, 48 degrees west of south, and you got 42 degrees south of west, just 90 minus, and then you're going that answer, and you will get that right answer. Okay? All right, so watch out for that. Because yes, that does happen on your unit test and your quizzes. But you already know, you saw that in your last test. Okay, so ladies and gentlemen, no, it's COVID, assuming we haven't shut down by then. Pray to God we haven't. Okay, so ladies and gentlemen, there are some practice problems for you to do. Take a crack at those. And if you guys have any questions, make sure that you ask, come to focus, and we will go from there. All right? Okay, lesson settled hint, this will be on your test. All right. So have a good day, ladies and gentlemen. We will talk to you guys all later. No fires, injuries, or explosions, and avoid rampaging viruses. All right, bye.